to the lesson, everyone. Thank you for making the time and giving of your energy towards improving your mathematics. I'm Claire, and let's get started with our arithmetic sequences work. We're going to look through the solutions to the exercise you were assigned on page 4 and 5 in your booklets. Let's get started. Let's not waste any time. So we're going to start off with the first question. We are going to determine the general term of the following arithmetic sequences. So I'm now on page 4, looking at question 1a. All right, so the pattern is going -1, 3, 7, and it continues. So let's remember or recall what our general term for an arithmetic sequence is. So remember, it's Tn equals A plus n minus 1 times D, right? Remember that A is representing our first term, N the position of the term, D the constant difference, and Tn is the value of the term. So in question 1a, we are trying to determine the nth term for this particular pattern. So this is super easy. We say that Tn equals A, term 1, which is -1, plus n minus 1 times your constant first difference. So let's just do this through observation because it's quite easy, right? Plus 4, plus 4. Remember our trick from our previous video, term 2 minus term 1 is equal to term 3 minus term 2 if the sequence is arithmetic. So if I went term 2 minus term 1 equals term 3 minus term 2, we see that our constant difference is 4. Right, so your final answer, Tn equals -1 plus n minus 1 times 4. Now remember I said that we can take this a step further, multiply out the brackets and add up like terms, but if we stop here, that's more than enough. Let's just do it for those of you who want to. So it's going to be 4n minus 4 minus 1. So the equivalent form for this would be 4n minus 5. Right, let's look at our next question, 1b. So the pattern given here is 4, -2, -8, and so it goes. All right, so Tn equals A, term 1, plus n minus 1 times my constant first difference. So let's again just do this visually. So you can go term 2 minus term 1 equals term 3 minus term 2. But I do think when it's really easy and obvious to see what that constant first difference is, let's just save a little bit of time. So we see that we have a constant first difference of -6. And that's your answer for B. Isn't this easy? Let's go on to question C. All right, so C, the pattern is 1, -1, -3, and so we go. I'm sure you're getting the hang of this now. Tn equals term 1 plus n minus 1 times constant difference. It looks like I am subtracting 2 between terms. 1 minus 2 takes me to -1. -1 minus 2 will take me to -3. Excellent. All right, so I'm just going to do in questions 1 and 2, I'm just going to focus on the highlighted questions. So let's move on to 2. All right, so 2a. Let's see what they're asking us to do. Determine the 38th term for each of the following arithmetic sequences. So they want us to work out in the 38th position, what is the value of that term? So remember I said it's very important that we distinguish between when are they asking us to find n, the position, and when are they asking us to find Tn, the value. So first of all, we have to determine the nth term before we can move on and find out that 38th term. Okay, so Tn equals a term 1, which is -4, plus n minus 1 times, let's determine our constant first difference. To get from -4 to -8, I'm subtracting 4. To get from -8 to -12, I'm subtracting 4. So I have a constant first difference of -4. Now, this is only a part of the question. We need to actually answer it in its entirety. Therefore, the value, remember that Tn is for value. The value of term 38 would be -4 plus the position is the 38th position minus 1 times -4. All right, and all we have to do from here is do this basic arithmetic. So it's going to be -4 plus 37 times -4. And we will arrive at an answer of -152. Awesome, well done. You've determined the 38th term, and that answer looks pretty good because we can see from the pattern how our numbers are getting smaller and smaller. A -152 is definitely smaller than those first three terms. All right, let's have a look at question B. Oh, we got some delicious decimals going. 2, -1.5, -5, and so we go. So you should be getting into the swing of this now. Nth term, Tn equals term 1 plus n minus 1 times constant first difference. Okay, well, let's see what's happening here. To get from 2 to -1.5, I must be subtracting 3.5. To get from -1.5 to -5, I must be subtracting -3.5. So my constant first difference, the value for D, would be -3.5. All right, so now that I've determined my nth term, I can now figure out what the value of the 38th term is. And all we do is we substitute 38 in the place of n. Right, and now I can solve. So just simplifying this, so you can just use your calculator, especially if you don't like working with decimals, but you should arrive at a solution of -27,5 or -27.5. Amazing, this is going super well. Okay, let's look at our next question, question C. Our pattern is going 99, 88, 77. Oh, we are going down in 11s. -11, -11. Okay, so I've already done the constant first difference for us because it was just so obvious to see. So nth term first, Tn is 99, term 1 plus n minus 1 times -11. Amazing. So therefore, to determine term 38, you should be in the swing of this now. We're just simply going to replace n with 38 and then solve from there. And if we simplify all of this, 37 times -11 plus 99, -308. Oh my word, we are just cruising through this work. All right, so D is 6, 21/4, interesting, 9/2, and so we go. So now we got these delicious fractions going on. I think at a time like this, it'll be really useful for us to go back to this concept, because it's not obvious if you say, so for the previous one, it was quite obvious to see what the difference was between the terms. Now that we work in the fractions, and I know that's not everybody's favorite, perhaps it's not so clear and evident to see. I'm actually going to put those there rather. So if I go term 2, 21 over 4 minus term 1, which is 6, is equal to term 3, 9 over 2 minus term 2, 21 over 4. Now, let's not be lazy. Let's not use our calculators. Let's just try to work this out ourselves. So 6 having 4 as a denominator would be 24 over 4. So 21 over 4 minus 24 over 4. What would that be? Negative 3 over 4. All right. If we do it on this side, so we're expecting negative 3 over 4 already, right? Because we know that since the pattern is arithmetic, this is true. So this would become, if we made our denominator 4, it would be 18, right, at the top, over 4 minus 21 over 4. Hooray! That's also minus 3 over, negative 3 over 4, sorry. So remember, you can just do this on your calculator though. But I like us to use those big, beautiful brains as well. So Tn equals term 1, 6, plus n minus 1 times negative 3 over 4. Amazing. So we've got the nth term, which allows us then to determine term 38. So 6 plus, in the place of n, we now replace it with 38 because we're trying to work out the value of term 38. Right, so if you want to work this out yourself without your calculator or just punch it into your calculator, we should arrive at an answer of negative 87 over 4. That would be your 38th term. Great. Let's look at E. So E is, so now they've given you the nth term, okay, but they've used the letter or the variable k instead. So I don't want us to be freaked out by this. If I rewrote this as, instead of the variable k, but I used the variable n, if I said Tn equals 3n minus 4, and now I'll ask you to figure out term 38, you'd say, oh, well, Claire, that's really easy. Term 38 would be 3 times 38 minus 4. 3 times 38, so that's 90, 114, 110. So don't be thrown off because I've used a k now, right? We actually, these two here are equivalent. They mean exactly the same thing. We just generally work with an n, okay? So don't let that now completely throw you off. If I rewrote it like this, I think that would be very understandable, right? If you wanted to work from this first initial, from the question as it is written in the textbook, T38 is equal to 3 times 38 minus 4. Okay, so K is interchangeable with N, is interchangeable with P. It can actually be any variable, right? But we know that we generally work with N. Okay, let's look at that last question then, because that's now looking similar. F is that TK is equal to negative 2K plus 5. So term 38 would be negative 2 times 38 plus 5. So that's going to be negative 76 plus 5 is negative 71. Whew, well done, everyone. We've gotten through those first two big questions very successfully. I hope at this point you're feeling comfortable with what we've done here. If you are not sure what's going on, you need to stop the video and you need to go re-watch the explanation videos. Go re-watch lesson 1 on arithmetic sequences and don't carry on unless you are sure of what you are doing. Let's move on then to our next question. let's have a look at question 3. Okay, let's get rid of all this. Right, question 3. I hope you're enjoying all my colors. I like all my colors. Okay, let's see what they throw at us. Which term of the arithmetic sequence, -5, -2, 1, is equal to 94? So what they're saying here is we need to work out in what position is there a value of 94. So remember, we're asking ourselves, are we solving for n or are we solving for Tn? And in these questions, in this one here, we're going to be solving for n. You should be realizing by now that we need to start off though with that nth term, that general term for the pattern. So Tn equals a, term 1, which is -5, plus n minus 1 times the constant difference, constant first difference, term 2 minus term 1 equals term 3 minus term 2. I'm adding 3 each time. So my constant first difference is a 3. Now, whether you want to at this point create that equivalent form or just start subbing in, that's up to you. I think I'm just going to start subbing. So the value is 94. So where do I pop 94 in? Do I sub 94 into n or into Tn? Okay, 94 is the value. Is Tn the value or is n the value? We know that Tn is what my value is. Okay, good job, guys. So where I see Tn, I'm now going to replace that with 94. Oops. So 94 is equal to -5 plus 3n minus 3. Okay, so I'm just multiplying, distributing that +3 onto the terms in the brackets. And now this becomes a very easy linear equation. So I'm going to, these terms here, right, the 5 and -3, we need to get rid of those. So 94 plus 5 plus 3, so that's going to be 102 is equal to 3n. To solve for n, we're going to divide both sides by 3. Right, so how many times does 3 go into 102? Right, so n is equal to 34. Awesome, that was pretty easy. So when you get a question like this, remember, we're going to sub, it says it's equal to a particular value. We're going to sub that particular value into our Tn, right? And then we solve for n. Okay, next question. Which term of the arithmetic sequence? Okay, so the sequence is going 4, 2.5, 1, etc. is equal to -66,5. What a juicy number. Right, so we need to work out nth term first. Tn equals term 1 plus n minus 1 times. Okay, we've got to figure out our constant first difference. So I'm going to do by inspection. I'm subtracting, let me do it down here. I'm subtracting 1.5 each time. Remember, you can do it yourself. Term 2 minus term 1 must equal term 3 minus term 2. That would also get you to -1.5. Awesome. So the value is 66,5. So do I sub that into n or into Tn? And yes, we're going to sub it into Tn because we know that that stands for the value. So -66.5, -60,5 is equal to 4 plus, oh, that's going to become a negative, right? Remember now what I'm doing is I'm distributing the -1.5 onto the two terms onto the binomial bracket. So the negative 1.5 times n, so I need to correct this quickly, that would obviously become negative 1.5 n. And then negative 1.5 times negative 1 would be positive 1.5. Right, now we need to go about solving this equation. So I'm going to put my n on the left-hand side of the equation, so it can be positive. On the right-hand side, then I'm going to have 4 plus 1.5 plus 66.5. So 1.5 n will be equal to, what does this add up to? 67, 68 equals 72. Right, and now we need to divide both sides by 1.5. And we will get that n is 48. Awesome. And we've solved and answered our question. Well done, everyone. I hope you're feeling good and that you're managing these questions. And again, if you are not, you need to go back and re-watch the video to make sure that we are all on the same page. Right, let's have a look at C. Ooh, this is interesting. Find the number of terms in the sequence. So, if you can recall from the previous videos, when I'm talking about when your sequence goes dot, 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 and remember I said when it goes dot, 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 like it is here, that's saying that the pattern continues indefinitely. And I did say in a previous video that sometimes the pattern does come to an end. And here is an example of that. So what this is saying is that this pattern, right, term 1, term 2, term 3, there's a whole bunch of terms in between, and then we come to the last term. All right, so minus 203 is the last term in this sequence. So this is a pattern which it comes to an end. All right, so I think you're starting to realize that even when you're unsure of what to do, it's always good to start off with determining the nth term. So Tn is equal to A, term 1, 12, plus n minus 1 times. I can still figure out my constant difference. I just actually need 3 terms for that, right? So I can see I'm subtracting 5 each time. So my constant difference is negative 5. Right, so let's read our question again. Find the number of terms in the sequence. So again, this is a solve for n question. We know the value of the last term is minus 203. My question is, what is the position of that last term? Is it the 50th position? Is it the 100th position? That's what we're going to figure out. But what's important is that you know that minus 203, we're going to pop it in there. So negative 203 is equal to 12. Right, I'm going to expand the brackets. Minus 5n plus 5. Okay, now I'm going to just solve this. So 5n will be equal to 17 plus 203, so that's 220, right? Therefore, n is equal to, so that goes in there, 44. Oh, this is such exciting, beautiful maths. Okay, so for C, you should have got a solution that 44, the 44th position, would be a value of 203. And perhaps it would be useful for me at this point just to give you a little trick, because you can actually check your work in this section very often. If I was to sub 44 into n is equal to 12 plus 44 minus 1 times negative 5. If I was to check my answer here by subbing 44 in the place of n, right, I'm hoping that when I simplify this, I should get an answer of negative 203. So let's just check. So if I go 43 times negative 5, that's going to be negative 215. And then if I add 12, that's going to be negative 203. Hey, and if I compare that, negative 203, that's the same value. So the wonderful thing is, I know that I've got the correct answer. So this isn't necessary. It's just a check that you can do for yourself to see if you got to the right answer, which you know you 100% have. Okay, let's move on. Last one in question 3 is D. Find the number of terms. Okay, so this is just the same as the previous one. Negative 55, negative 48, negative 41. And this pattern continues up until its last term, which is 85. Okay, so nth term, we know that that's how we start. So Tn will be negative 55 plus n minus 1 times, what's our constant difference? So to get from negative 55 to negative 48, I'm adding 7. So my constant difference is positive 7. Okay. So now, remember, the value of the last term is 85. So I'm going to pop 85 into here, and I'm going to solve for n. So 85 would be equal to negative 55 plus 7n minus 7. I'm going to work with the 7n on the right-hand side. So 55 plus 7 will be 62. So it's going to be 85 plus 62, which is 147. So therefore, n would be equal to 21. Awesome. Well done. And there we've mastered a very important concept and idea in arithmetic sequences, solving for n. And I really hope by this point we are determining the difference between when do I sub into n and when do I sub into Tn. Cool. Right, let's go on to question 4. All right, let's see what they're throwing at us. Given the sequence, negative 29, negative 23, negative 17, and so we go. A, determine the 31st term. B, which term is equal to 31? Right, so you're all saying in your head, okay, Claire, nth term first, and you would be spot on. So A is negative 29 plus n minus 1. My constant difference here is I'm adding 6 each time between my consecutive terms. So to answer A, what are they asking for? Term 31. So we're looking for the value of the term. And when I'm doing that, I sub 31 into n. Right, so let's simplify this. So it's going to be 30 times 6, 180, minus 29. So that's going to be 151. The next question is, which term is equal to 31? So the value of the term is 31. I want to figure out its position. So remember, I've just in the previous question got the nth term. So I'm just going to work with that now in B. So the value of the term is 31. I am trying to determine its position. So I am trying to solve for n. All right. So let's simplify. Some of you may do this in fewer steps. That's perfect. So I'm going to work with the n on the right-hand side since it's positive there. 29 plus 6 is 35. 35 plus 31 is 66. 66 divided by 6 is 11. Amazing. Isn't this work easy? It makes you feel so good. I just love sequences and series as a chapter. Cool. We're nearly there, guys. We've just got to do these next few questions. I'm proud of you. Keep at it. If you need to pause and take a break now, do that. Because it is quite a long video, having to work through all of these questions, but obviously very valuable that we go through them all thoroughly. Okay, let's have a look at question 5. Very similar to question 4. Given the arithmetic sequence, okay, so our sequence is going -13, -9, -5, etc. Right. Which term in the above sequence is 51? Right, so we need to get our nth term first. Tn is equal to -13 plus n minus 1 times. What's my constant difference, everyone? I am adding 4 between consecutive terms. Which term is 51? So 51 is the value. -13 plus 4n minus 4. Right, so 4n is going to be equal to 51 plus 17. So what's that going to be? 68. Oh, wait, I'm going to rewrite that. 4n, 68. Right, so now we're going to divide both sides by 4. So therefore, n is going to be equal to 17. Next question. Calculate the 51st term. So I want to know the value of the term in position 51. So term 51 is equal to -13 plus 51 minus 1 times 4. So therefore term 51 will be equal to, right, so this is going to become 50 times 4, which is 200, minus 13, it's going to be 187. Hooray, you are superstars. I'm so proud of you all. We're getting to the last 2 questions, guys, and these would be seen definitely as like the more tricky questions, and this was in the second video which was posted. So while I'm going through these and you really are feeling a bit confused, go back and watch that second video on the lesson 2 on arithmetic sequences, where we work with variables in our questions. Okay, but let's get stuck in. All right, so question 6 says your pattern is looking bonkers. It's P, 2P plus 2, 5P plus 3. Okay, so those are the first 3 terms of the sequence. The first question says, calculate the value of P. Now remember our very useful trick here. How term 2 minus term 1 is equivalent to term 3 minus term 2. This is a property of arithmetic sequences. And they've told you that this sequence is arithmetic. So you don't need to doubt using this. You know that that is going to be true. So term 2 is 2p plus 2 minus term 1, which is just p, is equal to term 3, 5p plus 3 minus term 2. Let's simplify each side. So 2p minus p will just be 1p. This is going to be, so again, some of you may not need to do this step, but I'm just going to do it so that everybody understands where I'm getting these values from. So 5p minus 2p is 3p plus 1. Okay, so now we just need to solve for p. So negative 2p would be equal to negative 1. Divide both sides by negative 2. P is a half. Don't worry about the fact that your answer is a fraction. I know how you doubt yourselves when you get answers that are not whole numbers, but we need to move away from that because very often your answers will be fractions, decimals, irrational numbers. Get comfortable with them. They are also beautiful numbers and we work with them very often. Right, our 6b says determine the sequence. So now remember what we do. In place of p, let's change this. In place of p, I'm now going to replace p with a half because I just solved for p, right? So using this pattern, where I see a p, I'm now going to write a half. So term 1 is p, so just a half. Term 2 is 2p, so 2 times a half plus 2. Term 3 is 5p, so 5 times a half plus 3. So therefore your sequence is going a half. 2 times a half is 1, plus 2 is 3. 5 times a half is 5 over 2, plus 3. So what's 5 over 2? 2.5. Plus 3 is 5.5. So if you want to write it as 5.5, or if you want to write it as 11 over 2, that's spot on. And there you can you can even see how our constant difference is going, it's consistent, right? So from a half to 3, we're adding 2.5. From 3 to 5.5, we're adding 2.5. So my answer is looking pretty darn good. All right, let's have a look at C. Find the 49th term. So by now we're going, all right, Claire, I know what to do. Nth term first. So Tn is equal to A, term 1, a half, plus n minus 1 times. Just spoke about how we figured out that the constant difference was 2.5. However you want to write 2.5 is up to you. We're going to get the same answer. I'm going to write it as 5 over 2. Okay, so just to go over this again, remember my constant difference is I'm adding 2.5 between terms. Okay, and that's why I have that over there. So now to figure out term, what do they want? Term 49 is equal to a half plus 49 minus 1 times 2.5, 5 over 2. So therefore, term 49 is going to be equal to 48 times 2.5 plus a half. That will be 51. Remember, you can just punch it into your calculator if you don't want to work with fractions. But I think this is good basic arithmetic to practice. It's really great. Let's look at the last part of this question, 6D. Which term of the sequence is 100.5? So, which term? That's when we're solving. Are you solving for Tn or n? Correct, you are solving for n. So we're going to put 100.5 in the position of Tn because that stands for value. It's equal to a half plus we're trying to solve for n. All right, so let's just go about first removing the brackets. So plus 5 over 2n minus 5 over 2. Okay, so now let's go about solving this. I'm going to work with the 2.5n on the right hand side. So it's going to be 100.5 minus a half, 100, plus 2.5. So that's going to be 102.5. So maybe here I write comma 5, or I guess we'll just leave it like this. Okay, so now we need to solve for n, so we're going to divide both sides by 5 over 2, and we will get that n will be 41. All right, so the 41st term would have a value of 100.5 or 100.5. Remember, you can always sub this answer now back into your nth term. And you can check whether you are right or not. Okay, last question. I'm so proud of you. Been working so well, especially with this stuff. This question 6, not super straightforward, but if you're managing these types of questions, you must be feeling good about yourself. Well done. All right, last question, question 7, part A and part B. This looks interesting. All right, so 7 says that the pattern is x plus 3, term 1, 2x plus 6, term 2, 3x plus 9, term 3. The first 3 terms are an arithmetic sequence. The first question says, determine the 10th term in terms of x. Okay, so in this question, they are not asking you to find the value of x. We need to read our question carefully. They want us to write the nth term in terms of x, right? And work with that variable. So your answers are going to contain numerals. They're going to have numbers and the letters in it, but that's fine. So the 10th term in terms of x. So this question is definitely like a through observation type of question, right? If you read the next, 7b says to determine the nth term. So we don't want to do that yet, right? That's a follow-up question. So by reading it, I'm seeing that they actually kind of want me just to look at the pattern and through observation determine what the 10th term would be. So let's look at what the pattern is. So it's going 1x, 2x, 3x. So the coefficient of x is corresponding with the position of the term. So 1x is term 1, 2x is in term 2, 3x is in term 3. So what's going to be in term 10? 10x. Nice. Okay, does that make sense? Term 1 had a coefficient of 1. Term 2 had a coefficient of 2. Term 3 had a coefficient of 3. So for term 10, we want the coefficient to be 10. Okay, now let's check out what's happening with these 3's. So 3, 6, 9, we can just see that these are multiples of 3. So term 1, 3. Term 2 is 3 times 2. Term 3 is 3 times 3. Term 4 would be 3 times 4. So what would term 10 be? 3 times 10, right? And what's 3 times 10? Plus 30. Oh my goodness, you guys are so smart. Well done if you got that all on your own. Right, B is determine the nth term in terms of x. So do you see that if I go back to A, do you see that your A has in terms of x? Because look, one of your terms here contains an x. So you don't want to be left with an answer where there aren't any x's. All right, so B is determine the nth term. So Tn is equal to A, which is term 1, which is just x plus 3. I know that looks weird, but that's what term 1 is. And it says in terms of x. So you're right. Plus n minus 1 times. Ooh, you've got to get your constant difference. So what is the constant difference here? Maybe this would be a really good time for this guy. You can just do it through observation, right? And some of you would have figured this out quite easily, but it's not too easy and straightforward. So I'm rather just going to go through it this way so everybody's on the same page. So I went term 2 minus term 1, term 2 minus term 1. So important, the brackets here is equal to term 3, 3x plus 9 minus term 2, which is 2x plus 6. Right, let's simplify each side. 2x plus 6 minus x minus 3 equals 3x plus 9 minus 2x minus 6. So x plus 3 is equal to x plus 3. Amazing. I love this. So our constant difference then is x plus 3. And you can stop there. That can be your final answer. All right. Well done, everybody. You've tackled some really interesting and beautiful questions today. I'm very proud of you all. Well done, and I hope that you have a very happy day.